guys, Miss Kulkarni here. In this video, we will go over reaction stoichiometry and how to work on some conversions from reactants to products and also from products to reactants. So, before we begin with calculation, I want to make sure you understand how we involve mole in all the calculations. So here is something I want you to memorize. The mole, I actually drew a mole there, but the mole is the heart. This is the heart. So it is the heart of chemistry. And just like heart pumps the blood out to different parts of the body, mole will be pumping out different directions to get to where we want. So this is our mole, which is the heart, and we can go in different directions. So if you want to go from moles to mass, which will be in grams, you're going to use the conversion factor molar mass. And now imagine you are traveling from Dallas to, say, New York. You're going to go from moles to particles. And what qualifies for particle? There are three things which qualify for particles. The atoms, that means they must belong to element. Then formula unit and molecules. Basically, these are same. It just depends upon if they are coming from covalent or ionic compound. So the currency which we are going to use is going to be different now. It will be Avogadro's number, which is 6.022 10 to the 23rd. Again, it will be a non-stop flight from Dallas to New York. Think about maybe now you're traveling from Dallas, if mole is Dallas, to, say, California, maybe LA, which could be volume of ideal gas at STP. Again, it will be a non-stop flight, so straight journey, and the currency which you're going to use will be 22.4 liters. Keep in mind, this only applies for ideal gas and they must be at STP, which means standard temperature and pressure. And we will talk more about that in gas laws. But right now, just keep in mind that if you're going to travel from mole to mass, particles, or to the volume, either of these, you can directly go in a non-stop flight. But if you're going to go from mass to particles, you must go via mole. So it will be mass to moles and moles to particles, and you're going to use the currency or conversion factors, which are molar mass and Avogadro's number. Let's actually work on a problem which will make the process much clearer. Either it is one step or it is two-step process. So in this equation, what we have to do is, first of all, write a reaction because nobody gave us the reaction. So what is happening here? How many liters of carbon dioxide gas at STP can be produced? That means it's telling you that carbon dioxide gas is a product from the combustion of that amount of molecules of cyclopropane. Now let me remind you again, molecule stands for particle. That means we are going from particles to final thing is liters of the substance. But let's understand our reaction. So this is cyclopropane. Prop stands for carbon atom number 3. So cyclopropane has the formula CnH2n. So if it is carbon atom number 3, hydrogen must be double of that, 6. And when it's combustion reaction, we are going to add oxygen, and the other two products which you're going to get are CO2 and H2O. And of course, you can write down the states for all that. But in stoichiometry, we don't need to worry too much about states right now. So I'm not going to worry about that. Let's actually balance the reaction. Remember how we balance the reaction? We got carbon number 3 here. So balance those carbon, 3 CO2. We got 6 hydrogen. We have to balance that. That means it will be 3 H2O. Come back to the right side and count number of oxygen. So 3 times 2 is 6 plus 3 times 1 is 3. What you got was 9. You divide that 9 by 2 and what you get is 4.5. So we are going to put 4.5 here. That's good answer in terms of mathematics. But if you want to do in chemistry, we cannot choose half of the mole. So we multiply the whole thing by 2 and your equation becomes 2 times C3 at 6 plus 9O2 is going to give you 6CO2 and 6H2O. So this is our balance reaction and we're going to work from balance reaction to make the calculations. So before we start our calculation, here is our balance reaction again. Let's draw our roadmap now. We are beginning from given, which is this many molecules of cyclopropane. That's my journey beginning from cyclopropane. And my destination should be liters of carbon dioxide. So I keep on traveling all the way over here and go to carbon dioxide. I need to end up in liters. So you can write down what you need to find out is liters. What's given to me here is 3.25 times 10 to 24 particles. Now we need to find out what is the pathway to go from particles to liters. So I'm going to take you to the roadmap which we got over here. In this case, remember, if you want to go from particles to volume of gas in liters, you need to go to moles, and from moles you need to come back to volume. In reaction, you will not be just going to mole, you will be going from moles of one reactant to moles of the second reactant, and then we'll finally reach your destination. So going back to our reaction, if I want to write this chemical as A, and I'm telling right now, I love to write A or B instead of writing the full formula. You can think Miss Kulkarni is lazy, but I don't like to write the full formula when I write the equation again. So if that is my A and this is my B, and you can select whichever letters you like. So I am going from A to B, the particles of A, to liters of B. And when I travel, the only way I can go from particles is to go to moles of A. And now I need to go to the different world, to the product side, but I need to go through moles. So I'm going to change my currency from moles of A to moles of B, and then from moles I can go back to liters. So the bottom line is you have to go through the moles. And the second thing is, once you reach to moles, you can go to either grams or liters, or it could be particles there, or vice versa. Now, with this roadmap in the system, I can write down over here what we got. So your beginning point is particles of A. And we'll go back and work on the numbers afterwards. From particles, you go to moles of A. Then you take your bridge and you go from A to B over here. So you go to moles of B. And from moles of B, you're going to go to liters of B. So we got our beginning point and destination. Now in order to get our dimension analysis in exactly proper way, we are going to crisscross cancel those units. So this is particles of A. I must have here particles of A. If I have moles of A here, I must have moles of A over here. And this is moles of B, so crisscross, I should have moles of B over here. Now, what do we put? Anytime there is a ratio of moles to particles, mole is always number 1. And what goes in particle? Over here, we are going to put Avogadro's number 6.02, 10 to the 23. Again, when it's moles to liter, you're going to use mole as number 1, and remember the currency. What we use? We use 22.4 liters. So we are set with that. We always begin with the given, and given in this case is 3.25, 10 to the 24. The only thing remaining now is the mole ratio A and B. What do we do with this? We look at our reaction and we find out the coefficient. So for A, the coefficient is 2. Go back and put 2 there. For B, the coefficient is 6. So go back and put that 6 over here. We are completely set with our dimensional analysis. Now it's time to cross out those simple units which are crisscross. So particles of A is gone right over here. Here goes moles of A and here goes moles of B. What we are left with is liters of B. B of course is carbon dioxide. And then we got all these numbers which you're going to multiply, and then of course we're going to divide with whatever you got. When you work on that calculation, your answer should be coming to 363 liters of B, which is carbon dioxide. Now, why did I round up my answer to 363? That goes back to sig figs. 3.25 times 10 to the 24, the sig figs go with that 3.25. And how many sig figs you got there? You got exactly 3 sig figs. So your answer is also rounded to 3 sig figs. Guys, I hope you enjoyed the video. I'll see you again in next video. Until then, bye-bye.